All right, welcome back to Genius. So in this session, let's talk about shallow and deep copying of lists. In the previous session, we took time to explain primitive and reference types. And it was because of this session that we have to do the previous one so that you will get to understand what is going to happen here. So with the understanding of primitive and reference type, you're going to understand the difference between shallow and deep copying and when you should do one instead of the other, okay? So in Python, shallow copy and deep copy are two ways of copying objects. Okay, so if you want to copy object, you want to make a copy of an object. Okay, you want to make a copy of a variable. Let's say you want to make a copy of a list. You want to make a copy of a tuple or a copy of a dictionary. All right, shallow copy is and deep copy are two ways you copy objects. So they differ in how they handle nested objects. Their difference is basically in how they handle nested objects. So if you want to copy a list that has a nested list, okay, if you want to copy a nested list, all right, that is where their difference comes. So we are going to actually see it. So the way you copy a normal list and the way you copy a nested list is actually different. And when you're copying a normal list, you don't really have to bother about shallow or deep copy. But when you're copying a nested list, you have to make sure that you understand what you're actually doing, okay? So a shallow copy creates a new object, all right? But it does not create copies of the objects that are contained within the original object. Look at what it means. When you do a shallow copy, you're creating a new object out of the original object, but you're not copying the nested objects. All right, it doesn't create copies of the objects that are contained within the original object. So instead, it just copies the references. So what it means is this. Okay, let me just show, right before I continue, let me just go to code and show you something. All right, let's say I have this x is equal to list, and I have it as a nested list. All right, I have 4, 5. I also have another one here. I have 6, 7. So if I do a shallow copy here, all right, if I do a shallow copy, it is actually going to copy it will give me a new copy, to create a new object, it will create a new copy of the how do I put it now, the top level. All right, to give me a new copy of the top level, but it is just going to copy the references of the nested ones. It will not see here. It will make a new copy of the original of the top level list, but these other ones, all right, it will copy them by reference. These ones inside here, it will copy them by value. Remember the value, copying by value and copying by reference. So it will copy this whole object by value. So these ones are primitive objects. It will copy them by value. But these other ones, it will copy them by reference. It means that in the new copy, if I go ahead and make change in this references, it will affect the other one. So look at what I mean. If I say y is equal to s, I'm doing a shallow copy here. I'm doing a shallow copy. So look at it. If I try to say y of, remember, if I want to have access to any of this, all right, so first of all, look at it. If I say print ID of x, and I also print the ID of y, you're also going to see that they are of different objects. It means that they were created, they are two different objects because they will have two different identities. Okay, so if I go on to clear and then run Python script, okay, they have the same, it is the same copy, all right? They are pointing to the same place, all right? But if I try to say, give me the copy, I want the ID of, this is 0, 1, 2, 3. So I want the element at index 0. Sorry, not 0, index 3. I want the index at 0, 1, 2, 3 because this one is at the index 3. Okay. And I also want the index 3. So if I try to print their ID now, let's see what it gives us. Okay. You see, it's giving us the same address. That means we copied a reference. All right. So when we say y is equal to x, okay, it is pointing to the same object. All right. It is pointing to the same object. That is why we have the same these objects, they are having the same ID. That is why they are having the same ID. Okay. So they are pointing to the same object. That's why they're having the same ID. So now this is shallow copying. So any change I make here is actually going to affect the other one. So if I say I want to make changes to the third element. So any changes I make, if I say I want to make change to the first element, if I change it to 7, then I go on to print x. Let's see what we get. You can see because I changed the first element, it reflected in this x. So the thing is this, what I'm doing here is that I'm pointing to the same reference. Y is pointing to the same reference to S. So this is not, this is basically deep copying. Okay, all right. So this is basically deep copying because we are pointing to the same reference. But now when we want to do shallow copying, look at what we did here. When I say Y is equal to S, Y is pointing to the same reference of S. So new object was not created, remember, because this is a reference type. All right, when we said Y is equal to S, we are pointing to the same object. That is why we were having the same ID. But when you do a shallow copy, all right, how do you create shallow copies of objects? The first one is you can use the copy method. So now let me make this difference very clear. When we were doing this, we were passing the same reference. So any changes we make here is actually going to reflect. And basically, the ID of Y is also the same, it's also the ID of X. Okay, so they are pointing to the same reference. But when I do a copy, when I say s.copy, when I use this copy method, okay, when I use the copy method, now I am creating I'm doing a shallow copy. So if I go on now to print their IDs, it will be different because Python is creating different objects. So I'm printing ID of Y. I'm also going to print the ID of X. So if I do this and save, I'm going to clear. If I run this code, you can see they have different IDs. The IDs are different because Python is creating a new object. But when I did Y is equal to S, if I do Y is equal to S, I am actually passing the reference. So Python is not creating a new object because this is a reference type. So when you assign a reference type to another variable, they will be pointing, Python will not create a new object. They will point to the same object. So if I try to do this now, you see they are pointing to the same reference, the same object. Python did not create a new object. But when I do a shallow copy by using the copy method of this list, Python is going to create a new object. So if I run this code now, they will not be pointing to the same reference. So they have different identities. They are pointing to different memory locations. I hope you understand the difference. So how do you create shallow copy? You create shallow copy by using the copy method of the list. Okay. So that's one of the ways you create it. So now look at it. Now we have created a copy. All right. So Python created a new object. Now, but look at it. If I go on and say, I want the ID of the element at index 3 of y and also the element at index 3. You might be thinking that they should be pointing to different locations, but no, for shallow copy, Python would not create a new copy of these reference objects nested inside of this object. So they will be, look at it, they are going to be pointing to the same object. Look at it. Why the element at index 3 of y and the element at index 3 of x, they are pointing to the same location, but the y and s are not pointing to the same location. So shallow copy will make a new copy, will create a new object of the top level object, but if they have nested objects, all right, Python will not create a new copy of them. So it will just copy the reference. That means if I make any change, if I say y is equal to, sorry, if I say y of index 3 is equal to, I'm not changing the whole list. I'm not saying 8, 9, all right? And I go on to print x index 3. If I go on to do this, look at what is going to happen. I didn't modify x. I modified y, all right? Now, because I'm modifying y, the index of 3 here, because Python copied a reference. So y is having a reference of this element. So since I modified this, the element at index 3, Python is now going to modify s. Because Python will copy the reference. Remember, when you make changes to references, to a reference type, and if you make changes to a copy of a reference type, it will affect the original copy. We talked about this in the last section. Now, I am trying to modify y, the element at index 3 of y. And remember, this element at index 3 is a reference to the element at index 3 of x. So since I modified y, x is also going to be modified. Okay. Why are we having, okay. I think there is a mix up here. Okay. I think I'm getting something wrong here. These two are pointing to the same direction, so a shallow copy. Okay, so wait, just give me a moment to put things together. Okay, now a shallow copy, so since it copies the reference to the original nested object, when I make changes to it, it's supposed to affect it. Okay, yeah, it is supposed to affect it. And let's go back. If I go on and print the ID if I go on and print the ID of y index 3, and I print the ID of x index 3, it gives me the same address, which means, oh, okay. They are not pointing to the same address, okay? They are different. So that is why when I modified y, all right, when I modify y, it's actually they are not pointing to the same address. They are not pointing to the same address. So that is why it had a copy of it. So it copied a reference to this one. So when you make changes here, it doesn't affect the other one. Okay. So let me still put this thing together. Okay. So if I print X, it remains intact. So I go on and I clear this. Okay. So now, one way you create a shallow copy, okay, don't worry, as we go on, I'm going to make this thing clearer. One way to create a shallow copy is to call the copy method. And when you do a shallow copy, you will be copying references. Okay, you will be copying references to the nested objects. So you can also use another way of making a shallow copy is using the list constructor. Okay, so when you say list of the original, you're actually going to be making a shallow copy. So if I say y is equal to, I use the list constructor like this. If I say y is equal to list of s, I'm actually making a shallow copy too. So you can use the copy method, you can use the list constructor method, okay? And then you can also use the you can also use slicing method. So if you use the slicing method, you can also create a copy of it. And if you also, there's also a module called the copy module. So if you use the copy module, you're actually going to be making a shallow copy. So let's go on and see all these things. We have seen the copy method. We have seen the list constructor method. So if I also say X, now this is slicing. All right, I'm also going to be making a shallow copy. So I can also import the copy module. I can also import the copy module. And with this, I can say copy, and I pass in, what am I copying? I'm passing X. All right, so with this, I'm also making a shallow copy. I'm also making a shallow copy. All right. So you see, I'm printing Y now. So I made a shallow copy of it. Okay. So now let's talk about deep copy. So a deep copy creates a new object and recursively creates copies of the nested objects found in the original copy. All right. So now what it means is this, it copies everything. For shallow copy doesn't copy everything. Shallow copy makes a copy of the top level object, but the nested objects, it will not make a copy of them. It will make references of them. All right, it will make references, or it will not make a copy of them. But for deep copy will make a copy of everything. So if you want to make a deep copy, you are actually going to use the deep copy method from the copy module. So when you do something like this, instead of using copy here, I'm going to say deep copy. And when I do this copy, so let us print the ID, or oops, sorry, I'm doing print. Let us print the ID of X and also print the ID of Y. You're going to see that yes, they will be different. The IDs will be different. All right, because it's a new copy. It is a new object to be created. All right, a new object to be created. So their IDs are different. But let's also check the IDs of their nested elements. When we did a shallow copy, their IDs have different. Okay, here their IDs have different. The IDs of their nested elements have different. They are different. They have different IDs. So when you do a shallow copy, you're only going to copy the top level. All right, but then you'll be copying the references to these ones. Okay, but when you do deep copy, you're copying everything. You're making a copy of everything. So if we go on now and say, we are going to say X of, we are going to say Y of 3 is equal to 8 and 9. All right. And let's print Y and also print S. And also print S. So if I save this, let me clear my terminal, then run my code. You can see here, this, maybe I'm doing something wrong here. Okay, let me just print, let me do something. So if I print Y, element 3, it's giving us 8, 9. Okay, but if I print Y, all right. Okay, no, yeah, okay. So I even got it. Okay, sorry. I thought it didn't show. I thought it didn't show. Okay, so let me print again. Okay, you can see that we have 8, 9 here because we made a change here. Okay, so but the S wasn't affected. Okay, but if it was a shallow copy, all right, let's print and see. Okay, so what do we have here? So for deep copy, all right, when you modify, okay, I think when I modify, so if I modify Y of, if I modify, yeah, I think this is what I was actually looking for. So if I modify the first element, if I modify the third element, okay, look at what I'm doing here. I'm picking the element at index 3, all right, which is this one. Then I'm trying to modify the first element. So if I run this now, yes, this has been my confusion. I was doing it wrongly. Now, let me explain now. Look at it, okay? If you do a shallow copy, all right? If you do a shallow copy, you're actually copying, Python will create a new object of the top level, but it will take a reference of the nested objects. So if you make changes to this, to the nested objects, it will reflect. But the mistake I was making is this. I was actually creating a new object altogether. Okay, I was creating, when I was doing this. So when I was doing this, I wasn't getting what I was expecting. So that was wrong. So if you make changes to any of this with a shallow copy, they will reflect. Because I was actually, I'm making make changes to a reference object. So when you make changes to a reference object, it will reflect. But if I do a deep copy, all right, if I do a deep copy and go on to make changes to this one, watch, it is not going to affect the X. Let me clear. I've done a deep copy here. I have done a deep copy. If you look at it, when I did a shallow copy, all right, when I did a shallow copy using the copy method or the slicing method or the list construction method or the copy method, all right, if I make changes to any of the underlying nested objects, it will reflect because shallow copy will pass in, will copy a reference. It will create a new object, but it will copy the references to the nested object. That is why when you make these changes, it will reflect. But if you do a deep copy, Python is only going to make a copy of all of them. Python will make a copy of the top level object and also a copy of the nested object. So it is no longer the reference of the nested object. So when you make changes to any of the reference object, the nested object, it will not affect the original object. That is why you see I made this change here, and this one is 8, this one is 4. So S is still returning its original copy. All right. But if it was a shallow copy, if I make this change now, S would also be affected. So if I print this, you'll see here X is affected here, but this one was the deep copy we did. X wasn't affected here. Okay, I hope you get that. So let's go on and now the summary of this. When you're using shallow copy, all right, shallow copy will copy the top level object only. All right, it will copy the top level object. It will create a new object for the top level object. But for deep copy, it will make a copy of both the top level and the nested objects. Then when it comes to their reference behavior, shallow copy will take references to the nested object. It will take references to the nested object. But for deep copy, it will make independent copies of the nested object. That is why when you do a shallow copy of the nested objects, it is actually doing a reference to the nested objects. And when you make changes to the nested objects, it will also affect the original copy. But because the deep copy is taking an independent copy of the nested object, they are different. It is a copy by value. So when you make changes to the new object, it will not affect the original object. So when you want to, when it comes to usage, you can use the copy dot. You can use the copy method in the copy module, or you use the slicing method. You use the copy method in the standard library of Python, or you use the list constructor method. But if you want to do a deep copy, if you want to copy everything and you don't want to copy references, if you want to copy everything independent of the original copy, you have to use the deep copy method. Okay, so which one is faster? Shallow copy is faster, but it's risky if you're working with nested objects. But deep copy is safer when dealing with nested structures. So when do you use any of them? Shallow copy is best when you use when your list has only immutable items. So if your list has immutable items if your list only has immutable items, then it is okay. All right, and you don't need to modify the nested objects. So if you don't need to modify the nested objects, it's okay. You can use shallow copy. But if you want to, you use deep copy when you need a completely independent copy, a new copy of everything. Shallow copy will give you a new copy of the original copy, but it will not give you new copies of the nested objects. But for deep copy, it will give you a new copy of everything. So when you modify anything when you modify nested objects using new copy, it will not affect the original objects, okay? So thank you very much. This session seems confusing, but please, if you find anything confusing, reach out to us, all right? Reach out to us, do your assignment, do your test, and we'll see you in the next session. All right.